Okay.
All right. Well, welcome everyone to our continuing web series for the ISA Mentor Program. Today we're starting with the first of hopefully many updates from the mentees themselves. So while this won't be nearly as complex as what Greg and Hunter and them tend to present, hopefully there's a little bit that can be learned. So I'm an engineer for Eastman Chemical Company, who I joined back in 2008. And in 2010, we bought another small plant and moved me into a role that did have some automation and process control responsibilities. I found out very quickly that I needed some help with some of this and was able to join up with the mentor program that was being formed back in 2011. So I've been with the program now for about 5 years. It's been wonderful. During this time, done things like joint articles. We printed them in Inset, Control Global. You can see one of the publications awards that Greg, Hector, Hunter, and myself won. I believe that was in 2013. We presented at Automation Week, Emerson Exchange, ISA's Fall Leaders Meeting. And if you happen to be coming to Exchange this year, Jim Cahill up on the right has actually invited all of the mentees to join him for a small get-together gathering at his house. So I'm looking forward to that. And finally, one of the more interesting opportunities that came up is I was actually asked to join the ISA's executive board to represent millennials and some of our, our younger constituents. So with that, in addition to talking about projects and things, I'd like to start with a quick update on some of the things that are happening with the ISA, and then move on to discuss kind of moving from a large site to a small site, how that changes things, typical responsibilities that I have, as well as some example projects that touch on automation and process control. And a quick note, since I didn't see that Hector was here to defend himself yet, but if you haven't looked already, he did have a member spotlight show up on the ISA's Insights page. So feel free to check out this link and see what some of our other mentees are up to. Okay, so swinging right into the ISA update, I thought it would be interesting because it's just something that I did not know until I started working with the board, how our mentor program actually fits into the ISA as a whole. There's three kind of main components of it. On the bottom right, you see the districts and sections. This is what we tend to see as our local sections, district meetings, district leadership events. So this is what most people have actually seen in the past. The middle is where the mentor program kind of falls in under the professional development committee. So along with that, there's also people that work on image and membership. There's the publications department that Susan Caldwell, who's been helping us out a lot, is very involved in. She's actually heading that department, and our strategic planning section. So all of these things are volunteer opportunities if any of you have an interest in promoting the ISA or working on our professional development or publication type of projects. And finally, there's the technical side of the society. So this is where we have the two big technical divisions, automation and technology and industries and sciences. So who go together and they put together all of these symposiums like the upcoming Process Safety Control Symposium. And last but certainly not least is standards and practices. This is a big part of what the ISA does, is actually write and maintain standards for various things related to the automation industry. So just if you kind of think about where we are, we're a part of that professional development program. Remember to hit page down. The executive board this year has 5 kind of large strategic goals, and I'll give you a very quick update on what's going on with them. On the side of improving our content, we do have a new technology search committee. They were formed last year, I believe, and they're currently reviewing all of the industrial Internet of Things type of updates to determine where the ISA needs to help out with either training or standards or anything around the actual application of IIoT. If you have any other technology ideas, they are taking those all the time at the ideas@isa.org email address. We're also working on using more data. So this is specifically using data such as business trends, marketing trends, to make decisions on what products we're supporting within the ISA, as well as all of our budgeting decisions. So I believe this goal has been going quite well, and we're making smarter choices by having the data to back them up. We have the goal of improving our coolest delivery, as they call it, and one of the things that will be, I think, of most interest to all of the folks in the mentor program is the skills assessment app. It basically goes through and looks at the entire body of knowledge and the certification process for certified automation professionals, and you can go through and kind of self-identify where all of your gaps in knowledge are. And once you've identified those, it will give you recommendations and resources to try and improve on them. We have a cybersecurity improvement goal this year. So the standard is out and gaining credibility. And we were very recently contracted to actually instruct a very, very large contingent of the National Guard in how to locate and deal with cyber attacks. And finally is our advocacy program. So we do a lot of advocacy for the industry, both at the student level and at the kind of adult professional level, and say more of the politics type of range. But on the student side, we do have an international goal of having 30% of our sections involved with either FIRST or Project Lead the Way or a similar outreach program for students. And we are not at that goal. So if you have any ideas or other types of programs that your local sections are involved with, please feel free to get a hold of me or any of the board members to let us know what you're up to so that others might be able to help. Some other kind of minor updates, but I thought they were cool enough to add in here. We do have a new website, or newly redesigned website, so that is still being worked on, but it has greatly improved over where it was. We started modularizing a lot of our courses. Instead of having people having to travel internationally for a 3-day course, now you're going to start seeing a lot of these courses chopped up into little online blocks and just available through the website. So I'm really looking forward to that change. We've been converting a lot of our publications to electronic format since there's a bigger demand for that, and we are really working on improving our video library. I know Greg and I both have war stories in there. I think Hector might as well. There's a lot of training, how-to videos that are going up. And Nick Sands, he's over in the picture on the right hand, is very involved with our standards committee. So he put together a short little video on how to actually get involved and help with standards if you have an interest. Other kind of oddball things, we do have new ISA merchandise if anyone's interested. So that's a couple of the logos show up over on the right. I really, really like that top one. So, but those are, t-shirts and coffee mugs and just other things to help support the industry. And we do have a transactions journal that's in its 2nd or 3rd year right now. So this is a academic journal, and is one of the highest rated ones for our industry at this point, just only in its 3rd year. I believe we had somewhere in the neighborhood of 12,000 papers submitted for the just a couple of hundred spots that we have for 2016. So it's really, really going well, and everyone's pretty excited about it. Finally, we have a couple of upcoming events. So the Fall Leaders Meeting, which everyone is invited to, is in California, coming up in September. We have a Strategic Automation Leadership Conference in October, and then I believe Greg is actually presenting at the Process Control and Safety Symposium in November. We did have some international events. Unfortunately, they just don't show up in the next couple of months, but we are trying to spread that out around our, I guess, kind of global presence a little bit more. So I'm going to stop here and take any questions on the ISA stuff, take some at the end as well, but the topics are different enough that I thought it might be worthwhile.
Danica, I was wondering if there's anything that they're planning to do to help increase the use of the ISA standards. I now know you can view them online for free if you're an ISA member, and of course you have to log in, and if you haven't done that before, you need to establish a password. But are they doing anything else?
In terms of kind of promoting them out in the industry?
Yes.
There's some work, a lot of that kind of goes through that advocacy program. So on the business side of advocacy, the year before last, I believe we actually purchased automation.com, which is a huge 100,000 member advocacy group for automation as a whole. So some of that kind of increased imaging and increased kind of publishing of all of those standards and talking about them has been happening through there. There's also some marketing that's being done through the LinkedIn groups as well as the ISA's Facebook page. So, but really it's just kind of getting to be known as the authority on things, and we're very, very close with cybersecurity to being the known authority for that particular topic. Wireless, we were a little late on in getting that standard out. So, but I still think that it's gone over pretty well and is getting to be reasonably accepted. So just getting people to get in and use it and know that that's where they should look. Does that make sense?
Yeah, thank you.
All right, well, I'll go ahead and keep moving on. Oh, go ahead.
Quick question. This is Zach. My question was, you mentioned the gap skills assessment.
Yeah.
Is that designed to be, if you're interested in looking at getting your CAP, is that aligned with that, or is that something different?
It is going to be aligned with that certification.
Okay.
So it may include some topics outside of that, but CAP is pretty extensive in the topics that I already covered.
Right. Okay. Well, thank you.
Oh, no problem. So pretty exciting stuff coming up. I think the staff at ISA as well as all of the various volunteers are working really hard. Okay, so I'm going to switch gears and start talking about more of what I do with Eastman. So you can see the picture down here at the bottom. This is our plant site in Kingsport, Tennessee, where I first started working. And on this site, there are over 7,000 people, and not including the contractors that we have, which can be up to a couple of thousand. So it's a very, very large, very complex site. You have very easy access to experts. All of your decision makers tend to be kind of within walking distance, and you just have an amazing amount of resources when you're at one of these mega sites like this one. So if you need any equipment, if you need to be able to get in and fill the heat exchanger at 2 o'clock in the morning, we have people that do that at that site. So it was a very, very interesting and very neat experience. But from there, like I mentioned in 2010, I moved to a small site. And when I say small, I mean tiny. So this is the entirety of it. We have about 50 people that work here. And there were some pretty major changes that I went through in what I work on and how I do projects. So a lot more flexibility in the business processes, mostly because 1 or 2 people are doing the entire business process from, cradle to grave. You have direct contact with vendors, contractors, and customers. But most importantly, to me at least, is I get to work on a variety of things and all aspects of a particular project. So all of a sudden, instead of having a DCS contact who was doing everything for me, I was then responsible for learning and going in and doing the programming, the configuration, and the control and troubleshooting of all of our instrumentation that I was installing. So this has been really, really a good experience. So some of the things that I do, I develop and manage capital projects. You can see my little bitty picture over here where I was supervising a lift we had for a propane tank. I directly support manufacturing, so you can see the DCS computers that I have in addition to the normal ones so that I can support them kind of 24 hours a day. Do cost and quality improvement projects, such as changing out this heat exchanger that was plugging. And I maintain all of our product and quality data. So in SAP and our laboratory information management systems, just a lot of different programs that have to work together and pass all of that information around. So a very large variety of responsibilities, very large variety of things that I do day to day. And I really, really enjoy that. So some of these projects, I've got about 5 or 6 on here. Some of them are larger and actually involve buying things. Some of them are what you would probably consider to be just an hour or two's worth of work. But I thought I'd include some of those as well, just for learning purposes. So this one here, we were trying to improve our reactor heat up. We had just installed a brand new super high powered hot oil unit that with this new hot oil unit, we were actually overshooting our temperature set point pretty significantly. And this was causing some quality issues that we had to rework. So we were looking for a way to minimize that overshoot without impacting our cycle time. A little more about this system. You can see the reactor down on the right. So reactor has an external heating loop, goes through a heater or through a cooler, and the temperature of that is controlled by a flow control valve on our hot oil supply line. That valve is in turn controlled by one of 3 different controllers. Either the reactor temperature, there's a column that you don't see that's on top of the reactor, and we have a DP controller on that to make sure that we're not flooding the column. And then finally we have a heat controller, a BTU controller, that helps us keep from boiling over everything in the reactor by heating it up too quickly. So of these, the logic would go through and do a low select strategy. So pick the minimum value of those and give that signal to our flow controller. So moving forward, we had a couple of different things that we tried and considered. First was just standard controller tuning, increasing the gain. And that just didn't get us the exact results that we needed. So you could basically either reduce the overshoot or you could reduce the cycle time. There wasn't a way to get both of them done. We did look at nonlinear tuning using the AntiReset windup limit, and I've got a slide here in just a few minutes that looks a little closer at that. But finally, we settled on the exchanger outlet temperature. So we have a temperature. See if this will let me go back up. We have a temperature on the exit of the heat exchanger, and so instead of looking at the reactor temperature all the time, towards the end of the heat up, when we start getting to that overshoot area, we can actually switch over to a controller looking at the exit temperature, and that gave us a much, quicker and more aggressive control action. So the justification for doing all of this work and putting the resources on this project was this quality improvement, which if you've ever done any type of justification for management, you actually have to take that to dollar numbers. So in our case, quality improvement had a very direct correlation to the rework time, so we were able to cut back our cycle time. And cycle time, in turn, depending on how your plant is running, how full you are in capacity, it's either going to be an energy savings or increased availability of production. So either one of which you can actually put into dollar values. So results, here's what that controller looks like. So the blue is a change in set point, and the green is our exit temperature. So they track really, really well, much less dead time and lag time than we had on the controller with just the reactor temperature. Did mention something about that AntiReset high limit, and basically you can set your output high limit on a controller different from the AntiReset windup. And when that temperature has kind of crested and is starting to move, your output's starting to move back down again. So you're almost at that point, your control valve is starting to close. As that's happening, the AntiReset windup, if you're above that, you're actually going to increase decrease the gain, many times over to cause a more aggressive action of the controller. Did I say that correctly, Greg, or did I get something mixed up?
Let's see. Look
at the numbers.
Between the output limit and the AntiReset windup limit, your reset action is like 16 times faster, greater. Yeah, so I'm trying to see here on the output, that would maybe help get you back a little bit quicker to set point.
Which was the intent. We couldn't quite get there as fast as we wanted, but that is something that you can look at, is that ARW.
Right.
Okay, thank you. I worry about getting those flipped. All right. One of our other projects that I was working on was improving our column temperature control. So in this case, we have our pack bed column on top of the reactor. It is mostly controlled in terms of temperature by a reflux stream. That's condensed vapor passing through a split range controller back to the column, and that's supplemented by a separate reflux header. And the bottom control is there in the blue, or bottom temperature is in the blue. You can see we have a reasonable initial heat up on our batches, but by the time we got to the late reaction, our temperature control was absolutely horrible. So what was happening is the batches kept failing. I call it failing, but this is just going into a held state because of high temperature spikes. So we started troubleshooting and eventually began to look at the instrumentation. So remember, we've got that flow element followed by the two control valves on a split range controller. So the red dots here is the output of that split range controller compared to the flow. And it kind of looks like somebody took a shotgun at it, which means that we've got really, really bad replication. So for a given output on the split range controller, you have absolutely no idea what your flow is going to end up being. This isn't actually a control valve issue though in this case. This is a flow element issue. So our flow meter that we had installed on this particular unit was sized for a completely different product that had a much, much higher reflux flow. So we are actually trying to operate this flow meter in the range to the left of that little operating range line. So our error is completely exponential at this point, and that's what's giving us the very, very poor control. So we needed to install a new RAS flow meter, and we were able to justify this on two different things. The first one, again, going to dollar values, is a cycle time improvement. So, and in this case, it was increased production. And we also had a safety justification here because we were going to be making this operate further away from that high temperature interlock. We wouldn't be putting the batches into held so often. Results were just pretty fantastic. So we went from kind of that poor oscillating control on the back end to relatively smooth movement throughout the batch. So the operators were all quite pleased with us, which I hope most of you know is the main goal of doing control projects, is making your operators happy. On a non-capital side, one of the ones that has also gotten us a lot of thanks in our department is turning off centrifuge alarms. Basically, we have several performance alarms on our centrifuges, things like if there's high or low torque, if the vibration gets out of range, just a couple of different indicators that we have on there to tell us when the centrifuge is operating poorly. Unfortunately, the way it was set up, whenever the unit is turned off for the daily cleaning, all of those alarms would occur all at once, and they would stay on until the unit was put back into service. So this became quite a nuisance with a lot of our operations. So solution on this one, we brought in a status mode from the PLC controller, brought that into the DCS, and then set up a little logic base there in all of our alarms that disables the alarm when the centrifuge is not turned on. So here we've got a condition block that's going to a positive and negative edge trigger. And if we go to the positive edge trigger, then that will enable all of those alarms, and the reverse if that signal goes from 1 to 0. So didn't really need any justification to spend time on this because of the fact that alarm management is already kind of a high priority for our local management. So they gave the go-ahead readily. but we did have a wonderful result and reduced a very significant number of alarms every month. Okay, here's another interesting problem that we have. This is a completely manual process where we've got a very, very small vessel. I mean very small, you can put your arms around it, that has a bunch of manual valves. So we use this as a charge vessel, and there's probably over a dozen different raw material tanks that all charge to that little tank. So what was happening, every now and then someone would accidentally leave a valve open, and upstairs they would see the 90% alarm telling them that they have a high level in the tank, but by the time they made it down the stairs, the tank would already be overflowing, so there wasn't enough time to react. Justification to do much to this in terms of automation was actually quite low. So we didn't have a lot of room here because of the fact that it's non-hazardous, it's inexpensive, there's a lot of valves that would have to be automated, so that the justification just wasn't there to do anything involving capital. So we could spend some time on it. Other things that we considered during our troubleshooting is we actually looked at putting the level alarm down to 20%. So, which works great until you actually try to use the vessel normally. So our solution was to actually put a snooze button on this alarm. That's what, at least we're calling it at this point. So the alarm has been lowered down to that 20%, and when the operators need to go out and use it as a charge vessel, they can put a 1-hour snooze on that alarm. It raises it up to 90%, counts down, the little countdown seconds there, and when that hits 0, the alarm will drop back down to the 20% level. So this has been working well, and the operators really like that they don't have to remember to turn it back on again after they get done with the charge operation. They can just let it time out, and it will go back to where it needs to on its own. Okay. In this case, we were having poor control issues on one of our tanks out in the tank farm. The product that we were storing in this tank is very temperature sensitive, and whenever the tank temperatures would get too high, the product would actually go out of spec and have to be reworked. So we did some troubleshooting, pulled maintenance in on this one, and we actually determined that our steam flow control valve is leaking through. And it's kind of important here to note that all control valves do leak through. There's some rate set by the manufacturer that they leak through at. In this case, we had more than we really wanted. So instead of trying to put in a control valve that had a really, really tight shutoff and wouldn't leak through as severely, instead we installed a block valve with a solenoid on the steam line prior to that control valve. And then we tied the block valve signal to the output of the control valve. So we've got our blue line in the little graph here. Whenever the output of that flow control valve got above 1%, you can see the block valve open. And then when it drops back down again, below that 1%, then the block valve automatically closes. Okay, so results were good. Our temperature is no longer rising. You can see on this first chart here that the flow controller is closing. This is prior to putting the block valve on there, but the tank temperature is still rising independently of that because of the steam leak. Once we put the block valve on, the control valve closes, which causes the block valve to close, and our tank temperature starts to drop like it should, just due to all of the natural heat losses. Okay. This project here, we are looking at control of our cooling water return temperature. So what we found is actually during an alarm management meeting, we were trying to figure out why all of our condenser temperatures were so high. And what we had found is that we managed to melt all of the internals of one of our cooling towers. So if you have plastic cooling towers, which is something that you can see we do here, this is very, very possible. I've actually also set a cooling tower on fire. So there are many things that you can do to cooling towers that I did not know were possible. But we linked all of this back, kind of did some root cause analysis, and found that some of the operators were turning down the flow to the condensers. We still have not figured out why, but they were turning that down. And this was leading to high cooling water return temperatures, which was damaging the packing, which was causing high cooling water supply temperatures, which was causing even higher cooling water return temperatures, and just turned into this vicious loop that basically destroyed the whole inside of the tower. So we put the tower back together, got it all fixed up. We also put some new alarms, appropriately justified alarms, on our cooling water return temperatures. We programmed logic in that would put batches into held if both the individual reactor cooling water return temperature and the overall cooling water temperature were above a safe point, as we decided. And we did spend some money. We took all of the flow meters that we had on our condensers, and we actually changed those over to flow controllers. And with the flow controllers, we were able to put a minimum flow rate on there that would keep us in a safer temperature region. So results were also good on this one. We haven't done any further damage to the towers, and we've been maintaining lower overall cooling water return temperatures. Out in our wastewater system, because we do have a wastewater plant here in addition to the other utilities that we have to run, we were looking to maintain our phosphate rate. So this is a phosphate target. And what makes phosphate control kind of complicated is the fact that this is all going to be based on your biological activity. So we needed to minimize breakthrough of the high phosphate just to kind of control what was going out in the water leaving the plant. So our solution is a very interesting split range controller. So you can kind of think of this as a hot water and a cold water valve that you're putting to make warm water. In this case, we put phosphoric acid and ferric chloride in. One raises the phosphate level and the other one lowers it. It gets complicated. All of the calculations and everything did have to include the phosphoric to phosphate and the stoichiometric ratios for the phosphoric chloride. So there was a lot that had to be included in that controller. But we did have very good results. We were able to justify all of the equipment that we needed to buy because this was a regulatory project. So this was not an option. It was something that the state mandated we controlled this phosphate level, and so we were able to spend the money we needed to do that. And everything is now working within our permitted limits. I think this is the last one. So this is a oxygen controller. It's actually also out on our bioreactor. So with the aerobic type of bioreactor like we have, you do have to maintain oxygen levels in there within a reasonable range. Otherwise, all of your bugs die. So here, the O2 levels, we were seeing them fluctuate just all over the place. It was very, very difficult control, and this was causing our three big air blowers to be fluctuating as well. So all three were needed, but they were turning on, turning off, and basically just cycling pretty badly with a large energy demand. When we looked into it, we found, again, that this was one of those things was tied to that anti-reset windup. So the ARW high limit was set to 100, but the output high limit on the blower was actually set to 1800. So basically for 1700 of the 1800 of this range going in one direction from that output high limit down to the ARW high limit, we had a gain that was 16 times smaller than when going in the other direction. So that was just wreaking havoc. So we set the ARW limit to the output high limit and then tune the controller normally, which greatly reduced the variability in our oxygen level and allowed us to turn off one of the blowers completely for much of the year, saving quite a bit in energy costs. All right, so I've talked some about what the ISA is up to, and as well as a kind of quick overview of some of the things that I do at the small site versus what I had worked on at the larger sites, and a few of the example projects that I have here that have been related to automation and process control. Are there any questions? I know Hector and I are usually the ones asking questions.
Well, one thing I'd like to note is that when you're between the output limit and the anti-reset windup limit, my understanding is the reset time is 16 times smaller, so you get 16 times more integral action, and in a few cases that's useful, but most cases that's just way too much integral action going on. And so when you went from Provox to Delta V, or I guess if, you know, for any system where that originally the output was in percent, like in Provox, and you go to Delta V where the output is now in engineering units, unfortunately, you got to remember to change the anti-reset windup limits as well, because their default is like 0 and 100, corresponding 0 and 100%. So if your engineering units are, say, 0 to 1800, you got to remember that, that anti-reset windup limit came in as a default of 100, and it really needs to be set up to 1800. You know, if you think about it, there should have been something to help warn you against that. But it's a common problem these days is understanding that when you change the output units to be say engineering units, you need to now realize your output limits and your anti-reset windup limits also need to be in engineering units. And in some cases, your outputs, like if you had a temperature cascade and your secondary temperature loop had a range of, say, 25 to 75 degrees centigrade, you know, that's that set point. Well, now your output of your primary loop, its scale should be set 25 to 75 degrees centigrade because it's manipulating that set point that's 25 to 75 degrees centigrade. So now that primary loop output has to have output limits, you know, 25 degrees as low limit and 75 degrees is high limit, and in most cases the anti-reset windup limit should also be set to equal those output limits, so they should be set equal to 25 degrees. So low anti-reset windup limit 25 degrees centigrade, and the high anti-reset windup limit equals 75 degrees centigrade. So yeah, that's a common problem, and there are some other problems, I guess, as you migrate from one system to another. Another common problem is that some older systems use the series form of the PID, whereas the newer DCF systems, the default is the ISA standard. Well, in the older DCFs, when you use the series form, you could set the rate time equal to or greater than the reset time, and you wouldn't get into trouble because the series PID had some interaction factors going on that actually effectively prevented rate action from dominating. You don't have that when you go to the ISA standard form. So you need to make sure that your rate time is not going to be about more than 1/4 of the reset time. And so people have literally taken their settings over from the old DCS system that had the series PID form, and they put it into their new DCS systems with the ISA standard PID form, and really gotten into some very severe oscillations because the rate time was so large and was either approaching the reset time or larger than the reset time.
Thank you, Greg. Anyone else? I know we've got some other presentations coming up here in the next few months. So hopefully I set the bar low enough for everyone.
That was great. Really appreciate you doing it. This is really what we need. We need the mentees to, tell what's going on with them, so we better understand, what the needs are. And I think Hector is going to do one, and so is Zach. And then you are as well. So I think the next three mentor WebExes are going to be done by mentees. So that's great.
If anyone would like to take the August one, that would be fine too. I can put together another presentation. It'll be on vacuum stripping, but it might be better to do that next year.
Okay, yeah, I think you're scheduled for, November?
Something like that.
Yeah, November. Okay, well, if somebody wants to volunteer to do November, that would be great. Otherwise, you're still on the hook.
Yeah.
Okay. Anything else? Tell you what, can each one of you just, maybe we'll go down the list, and, Adrian, and we can ask you and you can reply, did you hear everything okay, and was the quality of the video good? Well, maybe Adrian, yeah, okay.
Yeah, sorry, I was just on mute. And yeah, it was all fine. Thank you.
Oh, thank you, Adrian. How about Bill?
I've received everything fine. Thank you.
Oh, thank you. And Kamalu? Well, I'm not sure who Kamalu was, but Marcia, how about you?
It's really good. I was able to hear everything, and actually a coworker stopped by and saw what I was watching and commented that he thought it was good that I was watching it. So thank you very much.
Okay, great. And finally, Zach.
Yes, Greg, I was able to hear everything all right and see everything over there.
Great.
Thank you, and Danica, thanks for the presentation. It was great.
Oh, thank y'all for listening. I look forward to hearing what you guys are working on as well.
All right. Well, that does it. And I have a video, a recording of the video and audio. And ISA likes to, convert it to a YouTube video. And when that happens, I'll make it available to you guys as well. So thank you, and have a good day.
Talk to you guys next month.
Bye.
Thanks. Bye.
Thanks. Bye.